All right, welcome back to Anth 220 Nutritional Anthropology. This is going to be the beginning of our second lecture. I just want to introduce one of these macronutrients. So today we're going to focus on carbohydrates, sugars, starches, and fiber. Okay, so you're sitting there, wherever you are, maybe in your house, maybe in your car, maybe in the library, and you're thinking and you're listening to me talk. And as you're doing that, there are billions of glucose molecules in your brain, in the cells of your brain, that provide the energy required for you to think, for you to learn, for you to listen and memorize. Glucose fuels nearly all of the brain's activities, but most people don't walk out of an exam, for example, that you're pretty sure you aced and would say, "Wow, thank you, glucose." Or say you're running, and you're running a marathon, and you're winning, and you cross the finish line, and no one ever thanks the glycogen that fueled your muscles during the race. They say thanks to somebody else. Both glucose and its storage form are carbohydrates. And those two carbohydrates together provide about half of all the energy that your muscles and other body tissues use. The other half comes mostly from lipids. So today we're going to cover the basics of carbohydrates. And hopefully that will give you something to think about, not just during this lecture, but during this week and the week to come. We're going to come back next week and we'll tackle lipids and proteins. You might be thinking those examples I just gave of studying and passing an exam or running a race and winning and its relationship to glucose or glycogen doesn't really make sense, because of course you don't eat glucose or glycogen. You eat carbohydrates, right? And your body takes that and uses it immediately for energy. And it can also store some as glycogen for later use, energy reserves. Carbs often get a bad rap. And many people tend to think that carbs are fattening, and if you eat a lot of carbs, you're going to gain weight. And if you cut out the carbs, not only will you lose weight, but you're cutting out a negative aspect of your diet, that carbs are somehow bad for you. However, that is a misconception. That might be the case if the carbs are, for example, added sugars found in soft drinks and candy and some desserts. But if you're talking about whole grains and vegetables which have a lot of carbs in them, legumes also carbs, even milk has carbs, then it's counterproductive to think that all carbs are bad. Not all carbs are bad. Not all carbohydrates are the same. Let's look first at the monosaccharides. These are one of the simple sugars, meaning they have one molecule, mono, right? Mono, one saccharide. We are not going to go into the chemical structures in this online version, so you're spared for that. If we were doing this on site or maybe over a longer period of time, then we would do a lot more in terms of human physiology and nutritional biology. In brief, it is the chemical and in some cases the structural differences between the different monosaccharides that accounts for differences in sweetness of sugars. There are many, many different monosaccharides, but one of the most important ones, if not the most important one, is glucose. You might have heard this referred to as blood sugar. Blood sugar is the amount of glucose circulating in your blood. Not only is it commonly used in your body as an energy source, glucose, but it is found in every disaccharide. And it is the unit that polysaccharides are also made from, nearly exclusively. Polysaccharides, like starch for example, are the primary source of energy for people around the world. So we'll talk a bit more about glucose in just a few slides. We also have fructose, for example, that is the sweetest of the sugars. We find this in a lot of foods, but it's commonly associated with fruit, which is why fruit tastes good, because it's sweet. It's why primates, a lot of primates, eat fruit. They're attracted to fruit. Fruit is high in energy, and it also tastes sweet. And we have fructose in, for example, soft drinks and cereals and desserts, a lot of our products. And the last one is galactose. It's also a very common food sugar. And last are the polysaccharides, which I want to talk about in a few different slides. Polysaccharides are also exactly what they sound like. It's not a mono, it's not a di, it's poly. It's multiple sugar molecules. And almost exclusively, in most cases, it is multiple glucose molecules bound together. There are three important polysaccharides. These are glycogen. This is the storage form of energy in our bodies. We don't really find much glycogen in foods. It's in a number of plants, but absent or in low quantities in other foods. So we don't get it from foods that much. But glycogen is very important for our survival and the functioning of our bodies. Why? Because it stores glucose. Okay, we're talking about stores of glycogen. And say that's in your muscles, in your legs, or in your arms, and you're playing sports. Whether it is speed or strength or endurance that you need, your body is sending out hormones, specific hormones, which are proteins, which we'll talk about next week. So say a specific protein that carries a specific message. The message is, we need energy for speed, strength, endurance. The cells in your muscles release another protein, a specific enzyme, which is also a protein, and that enzyme attacks the branches of this glycogen, right? And you can see an image of that on the bottom of the screen, what that would look like. And suddenly, that cell is flooded with energy, glucose, which is now available for your body to use. And last are the fibers. These are a structural component of plants, and therefore they're found in all plant food. Now, I actually did a bit of research for many years that focused on various fibers. I will save you listening to all of that research. But if you're interested to talk about fiber, or you're thinking about doing a final research project on some aspect related to fiber, definitely come and talk with me. Okay, the difference between starch and fiber is that for starches, our bodies can break that down. We can break that down into its monosaccharide, glucose, and then we can repackage that as a polysaccharide that our bodies can store, glycogen. But for fiber, those bonds between glucose are different, and we cannot break it down. In some cases, the bacteria that lives inside of our digestive tract, which our digestive tracts do have bacteria, microbes that live in that, and that is part of a healthy body. That bacteria can help us break down some of the types of fiber, but not all. The fiber that can be digested by bacteria in our digestive tract, that type of fiber is called soluble fiber. This type of fiber is fermentable and dissolves in water. It helps protect our bodies against heart disease by lowering blood cholesterol, and it protects against diabetes by lowering glucose levels in the blood. So soluble fibers are good. The insoluble fibers are also good, even though you cannot access the energy. Your bacteria cannot ferment it. It is not soluble in water. But for those fibers, the insoluble fibers, they help you maintain a healthy digestive system. They help you to defecate. They help prevent diverticular disease, which is very common in both males and females between the ages of 19 and 60, and then extremely common after 60, which is the bulging of the lining of your digestive tract, sort of a weakening of the tract, and it can result in bleeding, which is generally not fatal. And you might not even know that you have this. You just need to eat healthy. In 80 to 90% of the cases, nothing needs to be done except for a change in your diet to including more fiber. Before we get into the next few slides where we'll look at blood glucose effects and recommendations related to carbohydrates, I just want you to keep in mind that we have already gone over a lot of different functions for carbohydrates. Blood glucose is almost certainly one of those topics that you have probably heard about, but you may not completely understand what this is or how it's related to nutrition or to health and a healthy balance that you are trying to maintain. Why is this important to you right now in your life? Well, every cell in your body is reliant on glucose for energy to some extent. Some cells, like the cells in your brain, your nervous system, are exclusively reliant on glucose. So no other monosaccharide will do. The activity of all these cells in your body, of every cell in your body, is continual. It's constantly active. They never cease. But there is a problem. Some cells can only store glucose, but many cannot, or some more can store a very, very, very tiny amount. The cells that store glucose are your muscles and your liver. So all those other cells in your body have to continually draw on the glucose from their environment. That's your blood, your body. So our blood has to continually flow, right? It has to bring oxygen and take out carbon dioxide, but it also has to continually bring new and fresh supplies of energy, glucose. But if you don't have enough glucose in your blood, then what happens? Right? You begin to feel weak and a bit dizzy. If you have too much glucose in your blood, if you just finished a meal where you ate a lot of glucose or a lot of carbohydrates, how do you feel? People tend to feel tired. And if you continually have too little or too much, this can lead to some serious health problems, including death. So, it has to be carefully regulated in your body, and that regulation involves a few hormones. Insulin, which I know that you have heard of. Insulin is a protein. It's a hormone, and it stimulates the movement of glucose from the blood into the cells. So it stimulates glucose uptake. So if insulin stimulates glucose uptake at the cellular level, where is the glucose coming from, right? It's coming from those storage units, glycogen. And we have to have another hormone that breaks glycogen down into glucose. We have glucagon is a hormone that stimulates your liver, which happens to store a lot of your glycogen, to break that glycogen down and send it to your bloodstream as glucose. After you eat a meal or a snack, your blood glucose rises, right? We have carbs and meat. If you didn't know that, carbs are in meat, carbs are in grain, carbs are in vegetables, carbs are in dairy products. And your body responds to that spike in blood glucose by increasing insulin in your blood, right? It's correlated. That hormone activates receptors in the cells which take in glucose. And like we just talked about, most cells only take in the glucose that they can use right away. They only take in the energy that they can use because they can't store it. But some organs and some cells of some organs can take in more because they can store it. Your muscles and your liver. So your blood glucose levels return towards normal values because you store excess glucose. But maybe, for example, you go a long time between meals, which happens to be not very good for your body because your blood glucose levels are going to drop below normal values. And your blood responds with the hormone glucagon. Glucagon, like insulin, is secreted from your pancreas into your blood, and it stimulates your liver to break down all that glycogen stores into glucose, and then it sends that out into your body to feed your cells. In light of what we just talked about with insulin and glucagon, this is a balance that your body needs to maintain, and you can help with how you eat and with what you eat. So eating a balanced diet that provides carbohydrates, including fibers, because fiber helps to slow down digestion and therefore absorption. And that means that glucose enters your blood gradually, and you don't get these incredible spikes, right? Also, eating regularly helps. If you go a long time without eating and you eat, say you eat regular meals, say you eat at 5 a.m. every day of the week, you eat at 5, you eat at noon, and you eat at 7. That's great. Your blood glucose is in balance. It's adapted to that schedule. Then maybe one day you don't eat at 5. You stay up really late and you sleep really late and you don't eat until 11. Well, that puts your body under a lot of stress. For diabetes, insulin does not effectively break down your blood glucose levels. You can manage diabetes by eating a balanced diet, eating smaller portions more regularly, eating at regular times, getting more fiber in your diet, having fiber in your diet reduces these extreme spikes in your blood glucose. And it's healthier not to have those spikes because that puts your body under an extreme amount of stress. Next, we're going to get into the effects of sugar. Most people get enough sugar in their diet, and the average American diet actually has an excess amount of sugar. Not naturally occurring sugars in foods like fruits and some vegetables and etc., but added sugars. A lot of our food has sugar that is actually added into it. Why? Because it makes that food taste more palatable. It gives a sweet taste to the food, and people like the taste of sweet. Not just humans, but most animals, most mammals. And we find a lot of added sugars in some foods, like desserts or candy, soft drinks, fruit drinks, etc. Sugar, it can taste good, but by itself, it doesn't really give you much besides energy, right? The more added sugars that you have in your diet, the more important it is for you to have a balanced diet, because it's going to be difficult for you to meet nutrient requirements for other things, like vitamins and minerals and protein and fiber, etc. And taken to excess, sugar can have negative effects. It can lead to obesity, chronic diseases, nutrient deficiencies, dental caries or cavities. We've got research going back decades showing that consuming sugary foods and beverages correlates with an increase in energy intake and in body weight and associated diseases like chronic diseases. Alright, this slide has the exact same text. I just changed the picture to show some products with added sugar. Some of these products we call empty calories, or in terms of what they provide to our bodies. And I'll touch on that in this slide. I want to talk about nutrient deficiencies. For example, say you're drinking a soft drink, just one glass. That's not too much. That's about 200 kilocalories of your daily dietary allowance in a 2,000 kilocalorie budget. And that's fine. But compare that to an individual that doesn't drink that glass of soda. Instead, that individual eats 2 slices of wheat bread with a bit of jam or jelly. Now, both individuals intake 200 kilocalories, but the person who ate the bread with some jam or jelly also gets 9 grams of protein, 6 grams of fiber, some vitamins and minerals, and some sugar as well, right, because of the jam or jelly. Now, we call foods like this, or sugars like this, empty calories, because it is energy dense but nutrient poor, right? I mean, for example, you can eat a spoonful of sugar or a spoonful of honey. Your body can't really distinguish the difference. They're both made of glucose and fructose. Or you can eat an orange, which actually has the same amount of glucose and fructose, and the same amount of kilocalories about as that spoonful of sugar or honey. But these two categories are not comparable in terms of nutritional value. They might be comparable in terms of energy, but not in terms of nutrition, right? The sugar in the fruit comes to your body in a package. It's packaged with water, with fibers. It's mixed with essential vitamins and minerals and other things. So we call things empty calories because they can actually contribute to nutrient deficiencies. If you are trying to maintain, say, a 2,000 or a 3,000 kilocalorie diet, or 4,000, doesn't matter, whatever it is, but say you get a lot of those total kilocalories from sources that do not give you much nutritional return, like a soda or soda, added sugars. That can lead to deficiencies in other nutrients. Now, of course, there is variation. This differs. Say someone that is incredibly active. Now, a lot of you that are enrolled in this course have mentioned that you are engaged in sports or you engage in physical activity. Maybe you can get away with drinking a soda or fruit juice or eating some of those sugary rich desserts. In fact, that might even be an important part of your diet in terms of energy balance. But for someone that is not as active, cannot get away with the same amount or the same frequency of sugary or added sugar foods and drinks. Okay, this is the same text, but I've just changed the pictures once again. Now, I just talked about empty calories, and I didn't put that in bold letters on the screen. It's just something that I talked about. That would be a good short quiz question for next week, for example, to test that you've actually watched this, you've listened to this, you heard me talk about a question that I'm going to give you, and you're thinking about what are empty calories. Anyway, I want to also talk about dental caries. Now, this is obvious. When you have sugary foods in your mouth, your saliva begins to interact with the sugar, and it produces an acid. That acid leads to tooth decay. But it depends on how long that food stays in your mouth, which partly depends on properties of the food, like, for example, how sticky that food is. You can eat a sugary food or a sugary drink and swallow it quickly, right? And that's great. You won't have much of any acid that builds up in your mouth. So there is a reduced chance of tooth decay. But you also lose some of that sweet flavor, right, if you chew it quickly or swallow it quickly. Or you can brush after a meal. That's also great. You remove all the sugar from your mouth, and therefore any acid buildup in your mouth that builds up because it's trying to digest or help the initial stage of digestion of the sugar. If you buy a soda and you sip on it slowly, say you drink it over 30 minutes or longer than that, well, that's actually really bad for your teeth. There's nothing necessarily wrong with soda in a larger picture, right, in terms of a balanced diet. But sipping on a soda or a fruit drink over a long period of time means that your saliva is constantly producing acid, and that food is very sticky, so it also stays on your teeth for a long period of time. It's actually much more beneficial, if you're going to drink soda, to drink it up and be finished with it. Alright, let's finish up with a few slides on the effects and recommended intake for sugar and carbs. I'm not concerned that you know all of these values that I'm going to tell you in the next 2 slides, but again, keep the larger pictures in mind. What are some of the effects? How does that relate to our culture? What are the functions? What are the different types of carbohydrates, etc.? So, in terms of sugar, there is no upper intake level. There is no estimated average requirement or estimated dietary allowance. The average American eats about 120 grams of sugar a day. That's about 500 kilocalories for a 2,000 kilocalorie per day diet. That is a lot of sugar. That's 40 ounces of a soft drink and 30 teaspoons of sugar. It's about 120 jelly beans. Looking at the USDA and the FDA recommendation, they recommend reducing the intake of sugars, or reducing the intake of kilocalories coming from sugars, especially from added sugars, and reducing this to about 125 kilocalories coming from sugar or added sugar per day. I mean, we are well above that. Next, we've already gone over carbs in general in the second part of the first lecture, so I'm just going over a few specifics here. In terms of starch and fibers, we talked about some of the effects there. They reduce heart disease, reduce risks of diabetes, improve gastrointestinal health or GI health, reduces cancer risk, help to maintain a healthy body and to manage weight. The average American eats about 15 grams of fiber per day, which is much too little. In terms of looking at the adequate intake, it should be about 30 grams per day for a 2,000 kilocalorie diet. If you're on a 3,000 or 4,000 kilocalorie diet, you'll need to increase the number of grams or the amount of fiber that you eat. And this is what we talked about in the previous lecture, looking at the acceptable macronutrient distribution range, which is a part of the dietary recommended intake. They suggest 45 to 65% of your total daily energy coming from carbohydrates. So if you're on a 2,000 kilocalorie a day diet, that's about 900 to 1,300 kilocalories, or 225 to 325 grams coming from carbs. Again, you don't need to know all of those numbers. I expect you to know the range and the effects and recommendation in terms of how that relates to habits of eating. Not all these numbers. You can look the numbers up at another time, right? But there is some variation here. The AMDR suggests 45 to 65%. If you were to look at the RDA, in light of reducing added sugars, they now set this more towards 130 to 150 grams per day. So eating less carbs. Still, carbs are important, but eating less, coming from added sugars. Let's go ahead and stop there for this week. Congratulations, you have made it through another week. You can always re-watch these lectures, take notes, make sure you take notes and you're ready for the quiz. And if you have any questions, email me or the GTF. We hope that you have a good weekend and a productive weekend. See you next week.